Hey everybody, Vermont Prepper here. I just wanted to go over my solar battery box that I've been building. Going to go over some of the parts as well as give you a screenshot of the diagram in case you guys wanted to do this at home. It's really not that hard. It looks like a rat's nest in there, but it's really not that hard to do if you have the time and the patience. And I did all the research already for everybody, so all you got to do is follow it. So here goes. Just wanted to show you where I came from. Started out with this little ammo box, 33 amp hour battery, has USB as well as cigarette light charger, has a SAE port to put your solar battery or your solar panel on, as well as a voltmeter right here. I'll turn it on for you so you can see it. Voltmeter and a 300 watt inverter. I built some others that have 400 watts, but this is the first one, so it's 300 watt inverter. Alright, so let's go over some of the parts first. And here's a nice screenshot. Hopefully you can see that. Now my lighting isn't the greatest, but I'm going to try and do this in one take. So you have your units right here. Here's your inverter, 3500 watt, 12 volt. I have two outlets hooked to the inverter. I have a 440 amp slow burn fuse, but first what I do is I put a disconnect in there so I could just shut the inverter off. It goes into a 440 amp fuse, and then that will go to your batteries, which are three 100 amp hour batteries in parallel, meaning positive to positive to positive and negative, etc. And it makes 300 amp hours at 12 volts. And what you'll notice here is I have my charge controller, and I'm going to show you all these parts in the unit in a second. Charge controller, you have a negative that goes, all the negatives go into this shunt, and I'm going to go over that in a second. And then you have where the solar unit panels, they're all hooked in parallel again. They go through a power pole connector into a 60 amp disconnect through a breaker, 40 amp breaker. I'm probably going to change that into your charge controller. Alright, and the charge controller, one side of it goes through a breaker into the positive terminal. Then you have the negative terminal, again going into that shunt. I have a USB, two USB ports with cigarette lighters, and I have a switch to turn those on. And you know, they're pretty standard wiring, positive to positive, etc., negative to negative. And then I'll run those through a 15 amp 15 amp fuse right here into the positive of the battery. So like I said, all the negatives here, any negative that you see, will go into this shunt. And what this shunt allows me to do is it allows me to measure the current and the status of the battery through this Victron BMV 712 monitor. Alright, and I'll be able to see how long the battery has left, what percentage it's at, the current draw, you know, power in, power out, etc. It's pretty slick, and you can do it from an app on your phone. You can monitor it from the app on a phone. Now, it is like $200, but I figured let me go all out for this one. I'm not sure if I'll sell this unit or not. We'll see. I'm going to get it working and get it real good, and it's way too heavy to ship. So I'd have to do it local on Craigslist. Alright, so let's get to the parts right here. I'll turn my light on. Okay, this green unit right here, that's my, they call it EDE-COA. It's a Chinese inverter, and before you guys throw stones at me, I did, this inverter cost $320, and it had some really good reviews on YouTube as well as on Amazon. So I went ahead and took a chance. $320 for a 3500 watt inverter, continuous power. is really good if you guys know anything about inverters. Okay, there is my 440 amp fuse, slow burn fuse. I have a battery disconnect that's for the inverter, and you'll see right here there are two sets of outlets, and I have them waterproof so I can have them outside. Two sets, GFCIs. And how I wired that is the inverter has 4 regular AC outlets. I got some 14 gauge outlet wire with 3 prongs at one end and a pigtail at the other end, and I just wired it right in to the outlets. And you see the batteries, I mounted 2 on the bottom and 1 on the top, and again they're in parallel. There's my Coleman charge controller. It's not all wired up yet, but this charge controller will allow me to expand to solar, to wind if I wanted to simultaneously, which is something I wanted to do, just not at this point. So that's why I chose this charge controller. You see, if you take this charge controller out, I have it hooked into the battery tray, and I have 4 foot of cable hooked up to it, so you can actually take it out if you want. And there you see the third battery. Here is a disconnect for the solar array, the 4 150 watt panels that I'm going to be using to charge this, and this is basically a 60 amp. We could really disconnect the power real quick. And then you see right here I have some off-road tires that I put on there. It's from Tractor Supply. I got them and I beefed it up with some plywood and some 2x6. And this thing's got to weigh 250, 300 pounds. Not really sure. Haven't weighed it. Over here again with the thinking of doing this outside, you know, working with it outside. I got a Pelican box right here. Pretty cool. I cut out the bottom. I have an oscillating tool that I cut out the bottom. Right here is the charge controller remote, so I could turn it on and off from right here. Here's my switch for USB. And this right here, I can charge with a regular battery charger. And what I do to charge that when I'm not using solar, so I have my Noco Genius, it's 26 amp, and this will charge AGM batteries, which this unit is. So I cut off the end of one side, and I made some power pole adapters, or connectors, and put a power pole connector right there, 45 amp, and thing charges like a charm. Does really good. Right here is the battery monitor that I was talking about, and that will allow me to monitor a whole bunch of different variables in the battery. And then right here is where I'm going to plug in my solar array. This is 75 amp power pole adapter or connector, and I'm going to hook up the panel right into here. So I'm actually going to put another Pelican box over this so that I don't have to worry about it getting wet. So that's it in a nutshell. Really, you gotta just take your time doing it, and I would appreciate any feedback. I'm kind of concerned about heat from the heat sink here on the inverter. I may put some extra fans on the side of it to cool it down a little bit more. I know it's a little tight in there, but I'm going to test it out first to see, and we'll go from there. If I need to put some vents and some extra fans, I'll do that, but it should work. It should be pretty good. And I'll next time I put a video up on this, I'll have it all working and actually test out some different things like tools and the refrigerator, microwave, etc. Anyway, Vermont Prepper out, and I would appreciate if you guys like this to subscribe, hit the like button, Comment. I would like to hear feedback about my wiring from some of you guys that are smarter than I am as far as electronics. I'm all self-taught. I do have an engineering degree, but it's not in electrical engineering. So anyway, I appreciate you guys taking a look at the video, and always be prepared. Vermont Prepper out. Take care, everyone.